Hey, hi everyone. Uh, so this is a short video demo on CipherPop Hackathon 2025. So this is my team. So Yogeshwar Gugure. So this is myself and Ashok and Parla and Ratnadi. So in this video, I am going to explain a short video on what are the themes that have been part of CipherPop Hackathon 2025 and what we have selected and all, and how we have implemented and how uh, we are going to take it forward. Okay. So basically there are two themes. That is on the next slide. Okay. There are two themes. So one is like tracing fake websites and all using AI and ML methods. And second one is tracing illegal cryptocurrency transactions. So we have selected tracing illegal cryptocurrency transactions. The main reason because I can show you in my mobile. So we are very much interested in using crypto. We are not part of any other crypto transactions like Bitcoin and all, but I have personally started mining Bitcoins, so which is also basically a crypto. It is not yet listed; just in mining. Still, it is in mining. So I just uh, wanted to show you once again. So this is how like I was and part of crypto. Uh, at the same time, I am very much fascinated towards understanding how this cryptocurrency works and all. So that is the main reason of choosing this particular theme for CipherCop 2025. And basically, we are software professionals of around having 10 years of experience. I'm basically a database developer, and now I am a data modeler. Um, Currently working for EY. So it's just my out of my pure interest. I'm working for this cryptocurrency Cypher Cloud Hackathon 2025. So let us move forward. So this is the main reason behind selecting this thing because I am very much interested towards cryptocurrency, and let us see how the future of cryptocurrency will be. Currently, Bitcoin is rocking, Ethereum is rocking. Let's see future what will happen. So briefly, this slide is just for 2 minutes. I will just go through very high level because uh, everybody who is part and going to be participated in CipherPop Hackathon 2025 will be having an idea about this cryptocurrency and all. But just for a layman who is watching this video, if he watches, just let him make him more understandable. So basically, cryptocurrency is a type of digital or virtual money that uses cryptography to secure the transactions. So the main key features is a decentralized. So there is no central authority like banks or government. So who is going to authorize? Whereas in case of cash flows and all, so and most of the cryptocurrencies they run on blockchain. It's a distributed ledger. So it is very much secure. Transactions are encrypted and verified by network participants, mainly like miners or validators. So basically now I have showed you the Python. So currently it is in mining position. We are mining it. So we are basically called miners. And also we validate. We currently we are validating some KYC of other applicants and all. So that is the reason it is very much secure and transparent. Why it is transparent is like all the transactions are recorded on the blockchain and can be viewed publicly. So there are private cryptocurrencies. Let us not talk about that currently. Bitcoin, the main currency crypto that is working right now, is public. So it is very much transparent and it is borderless. So we can send bitcoins sitting from your home to any part of the world. It's not like cash. So if you want to send transfer cash amount from one account to other account inside India, you have mobile banking and banking. But if you want to transfer outside India, then there are a lot of uh, other structures you have to follow. But whereas in crypto, it's like borders. There is no border, and it is limited supply. Okay, so irrespective of the inflation and all, okay, these are the fixed number of bitcoins, and only those bitcoins will be transacted. Okay, so high level examples of crypto: Bitcoin, first and more widely used; Ethereum, Ripple, Litecoin, Monero, Dogecoin. Let's move to next. So the previous slide will explain functional of cryptocurrency, how it will be transacted. So now it will show the technical side, what will happen. So basically, Yogesh, in my wallet I have some 12.5 bitcoins. So I want to transfer to Geeta's wallet some 10 bitcoins. So my wallet and myself, I will have one address, and Geeta will have one address that will be unique. And once I initiate one transaction, the transaction ID will be created. Okay, and the transaction will be pushed over the network for all the nearby nodes to validate whether that particular transaction is valid or not, whether it is double initiated and all. Okay, and some of the validators and miners will validate that. Okay, and once the transaction is approved, Geeta immediately in the Geeta wallet there will be 10 bitcoins, but she cannot able to transfer unless and until it is confirmed by some other 6 to 5 validators. So one it is validated, then the Geeta can transfer to some other place. Okay. So for each transaction there will be one unique transaction ID that we call a hash value, and how much number of bitcoins that we have pushed. Okay, everything will be there. And if you see, this is the JSON structure. Sorry, JSON structure. So if you see the inputs and outputs, okay, so the inputs will contain, so how you guys got that particular bitcoins from the previous transaction, and the outputs, okay, the Geeta's bitcoin address 10, and Yogesh change address 2.5, the remaining 2.5 bitcoins, and the fee of 0.005 that will be moved to miner who has mined that particular bitcoin and all. Okay. So this is how a crypto transaction will take place in the real time. So now, let us come to our main theme: how to trace illegal transactions. So let us come. This slide explains the key techniques to trace illegal transactions. So since many of the crypto are public, we can get the transaction details from blockchain.com API, Zephyr API, blockchain API, Etherscan. Okay. So now we have to detect the mixers or tumblers. Okay, there are different types of illegal, what we can say, patterns that most of the um, illegal transactions in the way, or else some drug dealers, drug peddlers, or else some other terrorist financer and all, how they use Bitcoin for transacting the money, and how they will escape by doing this illegal transactions. Okay, so they will employ detecting sorry they will employ the mixers or tumblers. Okay, and they will employ chain hopping, and they will employ peel chains. Okay, so our main agenda is to find out the pattern of that particular transactions. So if we found the address, okay, that is the main source for the transaction, and if we find the output of the particular addresses, transactions of the particular addresses, so from the main address, so to how many addresses it is going the amount, and in what way, and in what time period and all. So these are the main some of the important patterns that mainly are employed. So if you see fan in and fan out, okay, so the main thing fan out, so address A is the main address, and it is pushing into three other addresses XYZ through transaction ID 1, 2, and 3. Okay, so this is the fan out methodology, and the second one is fan in. From three different addresses, the amount is coming into address A. So I'm not saying these are the patterns that are completely illegal and all, but these are the red flags. These are the transactions that we have to make a look whether these are legally done, or is there some other legal methodology, the ideas of the persons who are using these wallets and transferring the money. So the entire thing is about just posing the red flag, saying we have found this pattern. Okay, and we need to backtrace whether these are valid or invalid by going to the exchanges where they exactly have the Bitcoin is getting converted into money, and there we need to go and we need to get the respective address, and so here the address is like some fixed hash value and all. So it's not like directly so Yogesh. It will not display Yogesh name as mm, a bank transaction. If you find out a transaction name, you find the account number, account name, PAN card, Aadhaar card, everything will be there. But here you will find only the hash key, and there is nothing you will really get out of it. So we need to the real challenges comes where we need to get the details based upon the address. We need to so that's none of our headache. Let us forget it for now as of now. Our main task is to mm, find the patterns for a particular wallet or address. Okay, so if the address is given and we need to fetch all the transactions related to the particular address, um, and if we can able to find any of the patterns that we are going to discuss now, then we need to make it as a red flag, and we need to analyze further. So, so this is a mixer or tumbler. If you can see, the middle point is the mixer. So what he will do, he will collect all the funds from different wallets and he will push the funds into different wallets. Okay, so that is mixer and tumbler graph. And field chain pattern, if you can see, wallet A, it contains 1,100 bitcoins and it will be pushing 99 bitcoins to wallet B, and wallet B will be pushing to 98 bitcoins to wallet C, and wallet C will be pushing 97 bitcoins to wallet D. Okay, so it's like a peeling off. Okay, so they will just keep some amount in their coins, and the majority will be pushed to other wallets. So that is the peel chain pattern. And the main thing is chain hopping, and the hardest thing is the chain hopping to detect, because um, inside the Bitcoin, if you want to analyze the transactions and all, okay, we can make it. But once at a particular chain, the chain will be break and it will move to another uh, crypto. For example, so if you can able to see here, so Bitcoin wallet is having 5 bitcoins, okay, and it will be sent to exchanger swap Bitcoin to Ethereum, and Ethereum we will have 80 Ethereum crypto coins. Okay, from it again Ethereum to XMR, XMR wallet privacy coin, cash out, and here is going to cash out. So chain hopping is a mechanism where um, for suppose there are 100 bitcoins. Okay, here he will be splitting into 30, 30, 30. Okay, he will give 50 packets. Okay, now this 30, some 60 will move to Ethereum, some 30 will move to another crypto. So this is where the chain breaks in the Bitcoin, Bitcoin, and the remaining will move to Ethereum. So it makes quite challenging how to track in chain hopping and all. Okay, so these are the different patterns of illegal activities. So we can sense that there is some illegal thing is happening. See, because if a genuine transaction will happen, or if you are going to purchase anything by using Bitcoin and all, okay, there will be only one single transaction. At most, there will be two transactions. But if for any particular transaction, if there are more than three or five, six, seven addresses involving in a particular transaction, and that too in this particular manner, so we need to make it a red flag and we need to analyze so that it will be helpful for sensing some illegal activities going on, and thereby if we inform to the law enforcement, from there they will take care what has to be done and what necessary steps have to be taken to either to avoid that particular illegal activity or else to reduce the impact of that particular. So now the technical approach how we are going to develop and all this. Okay, so let me go before going to the slide, let me show you a particular um, transaction, how it will be stored in uh, Bitcoin. So if you see, so this is how if we give one address to particular block cipher and blockchain and all, so we will get the details of the particular address, means how many transactions can be done and to which addresses and what amount and all, everything is found in this particular. We will get the uh, request or we will get the output from the API as a JSON format. So if you can see, this is the main address and these are the individual transactions that have been part of. Okay, and these are the inputs, these are the outputs. Okay, so if you can see, this is one transaction, this is one transaction, this is one transaction. Okay, so I'm just showing you an example. Okay, so these addresses can have many transactions involved. Okay, and in each transaction, so what are the all number of addresses that have been involved will be showed here, and out of that, what are the inputs and what are the outputs, everything will be shown here. So it becomes very difficult to analyze this particular JSON. So from which address it has gone and all. So here now we will make use of Python and Python libraries like Matplotlib and all. So which make our life very much easy to be so that all the particular techniques that we have patterns and all that we have discussed just now can be visually made possible. So so this is the Python code. Okay, so this get address. Okay, so what this particular will do, like, okay, it will go to the block cipher. Okay, and it will get the latest block and the particular hash value. Okay, um, and next, okay, it will get the recent address. Okay, so this is the black block data. Okay, so it's going for inputs. Just now we have shown the right inputs, addresses, and outputs, addresses. So it will return the list of addresses that are being part of. So if you see here, just now we have discussed, right? So it will go to the blockchain API, okay, and it will see a n number of addresses. Okay, it will look out for the latest block, okay, that has been part of the transaction, and that particular block, okay, it will pull all these particular addresses. If you can see recent real Bitcoin addresses, so these are all the Bitcoin. So now these particular addresses will be part of our input to the next final code. Okay, so if you see here, I have just taken one address for our analysis purpose. Okay, and we will fetch the transactions that are part of this particular address. Okay, so this fetch transaction, if you can see, it is going to hit blockcipher.com. Okay, for that address, and it is going to return the value. If you want, I can run it. Okay, and this is our Bitcoin address, and we are going to replace it with our address, and we are going to run it. Okay. So able to see, right? So this is the JSON. So the reply that we get while hitting this. So it will contain all the subsequent transactions that are part of this particular address. Okay, and now, so here you will get the transactional data, fetch the transactions. So the fetch transactions will give us all the JSON. So once JSON is come, we will put the JSON data into TXT, and we are calling analyze patterns, and we are sending the JSON as an input to this analyze pattern method. So if you go to the analyze patterns, okay, So we are getting the transactions. We're able to see here. So these are the transactions. So it's directly getting all the transactions that have been part of particular JSON, and they were stored in the transactions. And for each transactions, we are getting the inputs and outputs. So you can see this is the input, this is the output. Okay, and in other transactions, you can find the same inputs and outputs. And you can see if the length of the inputs greater than 5 and the length of outputs is equal to 1. So it's like a fan. Okay, so just now we have seen here fan. So if the length of the inputs is greater than 5, so here I have just kept 3 inputs, but if you can, I am my code I am flagging as when the input transactions are more than 5 and the output is only 1. Okay, all the 5 transactions are into only one output. Okay, then I am flagging it as a fan. And in the same way, when the length of inputs is equal to 1 and the outputs are more than 5, okay, then I am flagging it as a fan out and mixing. Okay, if the length of the inputs, let us go to the next slide. Okay, if the length of the inputs is equal to is greater than 3 and length of outputs greater than, okay, inputs and outputs are greater than 3, then I'm flagging it as mixing. And the peel chain. Peel chain is nothing but if length of inputs is equal to 1 and length of outputs is equal to 2. So here it is 1 input and the output is 2. 1 input and output is 2. Okay. So I'm just thinking them as a suspicious and then appending. Okay, I'm just keeping the list. And then whenever this condition is getting satisfied, I'm just appending into the list and returning the suspicious. If you can see here, we are just appending as it as a fan in and what is the hash value and what are the inputs and outputs. Okay, so that is how our code will run. So fetch transaction is done, analyze patterns is done. So if suspicion patterns are found, yes, then we are flagging it as a red suspicions pattern found. Okay, and we are printing the transaction type and transaction ID. Okay, or else if there are no suspicious patterns found, then we are seeing no major suspicious pattern detected. Okay, and then now we are going to the main part, the visualization part. So we are going to build and plot a graph. So here we are using the build graph. Okay, and for build graph we are using the transaction data and the suspicious patterns. The main reason for using suspicious patterns is to coloring purposes. So for to color the suspicious nodes and all. So here the node is nothing but the address. Let me come to build graph. Yeah. Okay. So if you see, this is the data and suspicious patterns we are forming. Okay. So here we are getting the transactions, transaction hash value, and the inputs, addresses, and output addresses. Okay. So this is we are adding the edge, address in, address out. What is the weight? Is nothing but the value. Value is nothing but how much number of bitcoins have been, the value of the bitcoin that has been transacted. Okay. So that is how we are getting the graph, and then we are plotting the graph. So we are plotting the graph here, plot graph. So here we are using the coloring. So if the node is equal to main address, we are putting it as a red. So that we can directly think, okay, this is the main address. And orange. So if the nodes are in suspicious addresses, then it is suspicious or stable. Okay. So now we are let us run this code. So we are also saving this particular graph. Okay. So BTC suspicious graph.pm. So if you can see here, this is a Bitcoin address that we are using for our analyzation. So here we can see red suspicious pattern found. So it's like a peel chain. Okay. So this is the details Bitcoin transaction flow. So this is our main node, and this here we can see a P chain transaction. Okay. So this here it can look possibly clear. Let us go directly. We can open the picture that has been saved. So here we can zoom in and zoom out, and clearly we can express. So if you can see, this is our main, and you can see the address written on top of this. Okay, and the arrow marks, you can see how it has been transacted. Okay, so here you can see this is the one that is showing P chain functionality. Okay, and these are all the other addresses part of this particular address transaction. So in this way, we are going to flag this, and we are going to analyze this particular. You can see the entire yeah. So the entire JSON that we are able to see here is entirely converted into a beautiful graph, and thereby we can start analyzing much easily, and we can also modify our code by setting up so maximum length of inputs. Okay, so if we can change maximum length of inputs greater than 2 and all, we can get fan in and all. Let us check. So in this way, we can easily start analyzing illegal transactions. So this is the one that I have been working on till date. Yeah. So let us come to the conclusion and future outlook. Crypto trading is very much essential for financial crime prevention and advances in AI and blockchain analytics improve detection. It's happening, and the main one more reason is stronger regulations and global cooperation. So at the end of the day, transaction is there is no border. So you can go to any other, you can transfer to any part of the world. And if you want to know the address details and wallet details, we have to reach out to the endpoint where the exchange and all is happening. So to reach there, global cooperation is the key. That's it. Thank you. Let me know if you have enjoyed this video. Thank you very much.